Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's really that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote. Here we go. The quote of the lesson is, "The great aim of education is not knowledge, but action." This quote is right up there with my favorite quotes of all time, which is why it opens the preface in the book. It only takes a quick scan to see how time permeates the TVM rules. This makes sense because time is the major point of TVM rule number 1 that includes both the in and different of the mnemonic or audible aid in different. So of course, the in and different, when considered separately, are going to have a time consideration, albeit minor. See what I mean by simplicity not being the absence of complexity? We've talked about this in a prior lesson. These rules weren't just slapped together overnight. The focus of this lesson is the timeline, in particular, how the numbers or period markers on top of the timeline will always count up from 0 by 1 for each period or payment, regardless of the time span in between periods or payments. So let's go through an example. I guess it's not so much an example as it is a drawing. I'm going to draw for you the way we don't do this. This is how we don't do this. Here's a 1-period timeline. And I'm using information provided in the second bullet here. We would not write it like this. 3 months, that's no go. We do not do that. We step up by 1. And so again, this is a short timeline. It's a timeline with 1 time span. And we like to fill in the blank. So how are we telling time on this timeline? Well, we're telling time with a quarterly time span in between the time period markers. And that matters because we can only use a true quarterly investment yield to work out the math. Here's a real-world situation to consider. There are a couple things I want to point out as you're reading through this example. First, notice how the word years appears in the first sentence. Now, a word like this can throw a lot of people off because here you have the flexibility to choose how to tell time on this timeline since you're not dealing with an annuity. You might choose to tell time with an annual time span in between period markers, but you don't have to. Ultimately, how you tell time on the timeline might be determined by the information that is provided with respect to the stated investment yield. In this case, as you'll see, it would be really easy to tell time with a monthly time span in between period markers. Second, the stated rate is not an annual investment yield. Traditional finance textbooks might lead you to believe that every rate or yield is stated in annual terms, but that's not real life. You need to know how to manipulate the yield or rate to determine the true investment yield. We've done this before, we'll do it again. What others might call the effective investment yield or effective rate. Again, fill in the blank for the duration, i.e. an effective annual rate, etc. So let's draw the TVM wallet. That's the starting point. This is the solution to analysis paralysis. It gets us off on the right foot along with the TVM rules and the mnemonic and audible aid and different. It doesn't need to be pretty. It just needs to be there. I'm also going to write in the 5 primary TVM variables or inputs, the keys you'll be using most on your financial calculator. And let's draw the timeline. This is an abridged timeline that includes 24 period markers. How are we telling time? We've got 2 blanks to fill in. We're telling time with monthly time span in between time period markers, so only a true monthly investment yield will work. So down here in this blank, we want to fill it in with an M to remind ourselves of how we're telling time on this timeline. Now let's write out the building block true investment yield equation, because we need to calculate the true monthly investment yield. There it is, the building block true investment yield equation. So let's fill in the values for these variables. We were told that the simple semi-annual investment yield is 1.5%. So this is that expressed in decimal format or decimal form. We were also told that compounding happens monthly. So over that 6-month time period, compounding will happen 6 times. So lowercase c takes the value of 6 here. Okay, let's pause for a moment before we work this out all the way to I. We started with a simple semi-annual investment yield of 1.5%. 0.015 is the decimal form of 1.5%. That's what we see in the numerator. When we divide by 6, why do we divide by 6? Because we were told that compounding happens monthly. So compounding will happen 6 times over that 6-month or semi-annual time period. When we divide by 6, what are we left with? We're left with a simple monthly investment yield. Now, we're looking for the true monthly investment yield. And if you're following along and if you're thinking about this critically, you might be wondering, well, why don't we just end here? Why do we even need to add 1 to that within the square brackets? Aren't we good? I think it's good form to take it all the way out to I. Why? Well, but for the building block true investment yield equation, so in other words, in all the building block present value or future value equations, whether for a single or lump sum or an annuity or a perpetuity, you won't find S or C anywhere. You'll find I in every equation, and so that's why it's good form to take it all the way out to I. So we raise this to the power of 1, we subtract 1, and we get I, which is 0.0025, that's the decimal form, which is 0.25%, that's the percentage format, and that is a true monthly investment yield. So now we've matched our lowercase I with our lowercase n. Remember the visual that we're going for with the timeline, it's as if there are lowercase n's that are being rotated down 90 degrees until the serif at the top of the stem and that lowercase n, all the lowercase n's, form the time period markers on the timeline. That's the visual that we're going for. So if you haven't watched that video relating to that lesson, I think it would pay to go back and press play and to watch that, because that's the visual that we're going for. I know a lot of us are visual learners. I definitely consider myself in that category, and so I think it would help. So here we're solving for the present value, so we're going to circle that. We want to have $10,000 in the bank 2 years from now, more precisely 24 months from now. PMT payment is 0. Why? Because there's no annuity here. There's no payment that is level or even in terms of amount and timing. We're dealing with a lump sum payment. What we want to have in the future, 24 months from now, in the bank. There are how many months in this 2-year period? See, that's why we put that subscript there. That's why we fill in the blank. Over a 2-year period, there are 24 months. We know that. but again, it's just good form to do it this way. And the true monthly investment yield is 0.25%. Now, I've got to input it in the percentage format in my trusty HP12C. Your financial calculator may be different, but that's the way that I need to do it. And when we solve for PV, we get negative $9,418 and, let me make sure I get this right, 35 cents. There's at least one thing I want to point out here, and that is the negative sign related to the present value. Why is it negative? Well, the way to think, we can go back to TVM rule number 3 for more guidance, but the way to think about this is those monies would need to be deposited or invested. They would have had to have left your hands if you hope to have $10,000 24 months from now and you think that the true monthly investment yield over that investment period is going to be 0.25%. So that's the way to think about it. That's the way to talk about it. We like to double check our work, and so that's what we're going to do here with the building block present value equation. PV equals FV divided by 1 plus I raised to the nth power, and that's uppercase N. So let's work through this. PV equals, we want to have $10,000, and we want to have $10,000 24 months from now. In parentheses, we add the decimal form of the true monthly investment yield to 1. So here's how it looks, 0.0025. Let's pause here for a moment. 0.0025 is the decimal form of 0.25%. That is a true, fill in the blank, monthly investment yield. So how many months are there over this investment period? 24. That's why uppercase N takes the value of 24. That's why we raise this 1.0025 to the 24th power, or the power of 24. And when we solve for this, we get $9,418.35. Now, one thing to point out before we move on, there's no negative value on this slide. When we are working with the math, in particular, the building block time value of money equations, we don't have negative signs related to, I mean, there are negative signs from time to time, but there are no negative signs related to lump sum payments or annuities, or in the case of, an annuity on steroids, perpetuity. We don't have it. So there we go. We double checked our work, and that's great. That's why we do this. Here's another real world situation. Here, notice that the compounding detail, while nice, doesn't change anything if we want to tell time with a semi-annual time span in between period markers. In that case, the stated yield does the trick. Also, in this example, the word years appears in the last sentence. As you'll see, we're going to be telling time using a semi-annual time span in between period markers on the timeline. Why? Because we can. We have that flexibility. We're not dealing with an annuity, and because the stated yield is a true semi-annual investment yield, and 2 years is divisible into 4 semi-annual periods. So it's just easy. It makes sense. So we're going to draw the TVM wallet. That's the first step. As we draw the wallet, even if we're doing this subconsciously, hopefully we're thinking about the TVM rules, because remember, each window in the TVM wallet relates back to a TVM rule. The first window relates to TVM rule number 1. The second window relates to TVM rule number 2. And the third window relates to, you guessed it, TVM rule number 3. So I'll erase that, but it's just a good reminder. So we've drawn our TVM wallet. Let's write in the 5 primary time value of money inputs or variables. These are the keys that you'll be using on your financial calculator more often than not. And in this case, since we're telling time with a semi-annual time span in between period markers, we'll just draw out the full timeline, unabridged, because we can. Let's fill in the blank. How are we telling time on this timeline? Well, we were told that the true semi-annual investment yield is 1.5094%. That's a true investment yield. We can use it so long as it matches how we're telling time on this timeline. We've got the flexibility to choose how we're telling time on this timeline because we're not dealing with an annuity. And this time span in between period markers is a semi-annual time span. In other words, 6 months. We're going to fill in this blank to remind ourselves how we're telling time. And there are 4 time periods over this, 4 semi-annual time periods over this investment horizon. Here we're solving for future value. So we're going to circle that. And we start with $9,418.35. Negative $9,418.35. PMT payment is 0. Why? Because we're not dealing with an annuity, as I mentioned already. Before we solve for future value, and we're going to be double checking it in the next slide, this is how we do it, I want to show you how the true semi-annual investment yield would have been calculated using information from this example and the prior example. So again, the building block true investment yield equation is the starting point. This is the value that we have for lowercase s. This is the value in the denominator for lowercase c. There are 6 compounding periods over the duration of the simple, in other words, it's nominal, it doesn't consider the effects of compounding, investment yield. And lowercase n would take the value of 6 here. We would work this out to 0.15094, that's a decimal format. 1.5094 is the percentage format. And this is a true semi-annual investment yield. It was given, it was stated, and so we didn't need to do that math, but I just wanted to show you again how that rate would have been calculated. And when we solve for the future value, we get $10,000. You may have guessed that was coming. Again, let's focus on the third window in this TVM wallet before we move on to the double check. Notice there is a negative sign. And think back to TVM rule number 3. We have to consider the different payment types and signs. So negative tells us that those monies would need to be deposited or invested. They would need to leave our hands. If we expected or if we wanted $10,000 after 2 years, more precisely 4 6-month time periods, and we thought that we could earn a return on invested monies of 1.5094%. And again, that's a true semi-annual investment yield. Let's move on to the double check. This time we're using the building block future value equation. Future value, FV equals PV times, I like to put a multiplication sign there, 1 plus I raised to the nth power, and that is uppercase N. FV equals $9,418.35. Notice there's no negative value associated with that, times 1 plus 0.01594. So it's 1 plus the decimal form of the true semi-annual investment yield. How many semi-annual periods are there in this investment horizon? There are 4. That's why we raise this to the power of 4. That's the value for uppercase N. And when we work it out, I'm happy to report that we get the same value that we determined using the TVM wallet, and that's what we want. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. You know, it's easy to draw a timeline, about as easy as drawing a stick person. But not every person who is an aspiring or current finance professional, sad or scary as it is, can actually draw one correctly every time. And let's face it, it's not the drawing that matters, rather knowing how to apply the mathematics of finance to analyze and evaluate real-world time value of money situations. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return? Until next time, enjoy the gift that is the present.